In this lesson, we shall focus on Maclaurin polynomials. We shall look at these tutorial questions. We shall begin by looking at the problem number 9 in an attempt to cultivate the skill that is necessary on the Maclaurin polynomials. Now, the couple of things that remain very important for us to take into account, and it is exactly how we deal with the notion of the Maclaurin polynomials. Right, so what is the formula for the Maclaurin polynomials? To master the Maclaurin polynomials, you need to look at the formula. So what is the formula? Right, as you can see, the answer is this. So the formula is going to be Pn of x is equal to f of 0 plus f prime of 0. Okay, first, because now mastering the Maclaurin and the Taylor is just about the formula. If you know if you learn the formula, then you just substitute into the formula. F 0 which is Fn okay, so this is what we have. This is what we have. So this is what we have now. This is Maclaurin. This is the general Maclaurin polynomial of degree n. So now this one, we call it the Maclaurin. The Maclaurin polynomial of degree n. This is the formula. That's all. If you know this formula, it's everything you need about Maclaurin. So if you learn this formula, to solve any problem, we'll have to write this formula first. Now, let us look at the problem number 9. We have f of x, which is the square root of 1 plus x, which is 1 plus x to the power 1/2. Let us find some derivatives of this. So you bring 1/2. So you have this, you bring this one down. We have this. Bring this one down. And then now it's a third order polynomial, so you can stop here already. Third order polynomial, because this one is it's a Maclaurin polynomial of degree n, or nth order, right, which is x to the power n. So now, third order, we stop at the third derivative. Let us find f of 0. What is f of 0? If x is 0 here, it's just going to be 1. F prime of 0. This one, with x is 0, 1/2. F double prime of 0. If x is 0, it's going to be minus 1/2. F triple prime of 0. which is 3 out of 8. Okay. This is everything we need. And then if this one is the Maclaurin polynomial, then we need a third order. So we're going to put P3 of x. What is f of 0? F of 0 is 1. So we put 1. And then plus. Then we put f prime of 0, 1/2. And then here, minus 1/4. So you have minus 1/4. And then third order, so you're going to do the third one. The third one, you're going to do the third derivative, which is 3 out of 8. And then it is x cubed divided by 3 factorial. Then you stop there. Okay, so you need to simplify this one. P3 of x, 1. You divide by the 1 factorial, which is just 1. So this is of x. And then now you come to this. 4 times 2, 8. X squared. And then this 3 factorial, it's 6. And then what you then have is 3 like this, and then it is 8 times 6, which is 48. 48x cubed. P3 of x, 1 plus 1/2 x minus 1/8 x squared. 3 goes how many times into 48? 16 times. Okay, so this becomes the answer. This becomes the answer. This becomes the answer. This is the answer. So any question? You need to make sure you understand, because this is the truth is with this, then we're going to do the next problem. And the next problem is problem number 10. 10A. But the way we're going to do 10A, we're going to do it in the same way. Exactly in the same way. Exactly in the same way. So we're going to have 10A. Do 10A. We write down the formula for the Maclaurin, because you need to find the fourth order Maclaurin. So the formula says f of 0, always. F primed of 0x over 1 factorial. Which is x squared over 2 factorial. Of 0x cubed over 3 factorial. And then you can do fourth of 0x to the power 4 over 4 factorial. So okay, this becomes the thing we have. So we have the cosine of pi x f primed The derivative becomes, the derivative of the cos is minus sine, but there's a pi, the sine of pi x. Derivative of the sine becomes cosine, but there's a pi that's going to come out. Pi squared cosine pi x. Third derivative. All right, so the third derivative is going to become the derivative of the cosine becomes negative sine. It's going to become pi cubed with the sine of pi x. The derivative, therefore, of the sine becomes cosine, but the pi comes out, which is 5 to the fourth power cosine pi x. Okay. Now we have this here. And what you need to do is to be in a position to determine the fourth order Maclaurin polynomials of this. But let us find f of 0. Cosine 0, 1. 0. Which is 0. So just substitute the 0, the second derivative is minus pi squared. The third derivative, 0. Which is the fourth one, which is pi to the fourth power. So that then you have, okay, here you need the fourth order. So the fourth order, you can call it P4 of x. So you start f0 is 1. F prime to 0 is 0. And put 0x over 1 factorial. The second one is minus pi squared, 2 factorial. The third one is 0. Put here 0x cubed. The fourth one is pi to the fourth power. That would be the fourth one, and then you have P4x. Right, so you just simplify this one, and then this one is going to be 0, and you have minus pi squared over 2, because 2 factorial is 2, and then you have x squared, 0x cubed, and then you're left with 4 factorial is 24. So you have this. So this is what we have. Okay, so this becomes the answer. This becomes the answer, which is exactly the answer they got there. So this is everything Maclaurin. Everything Maclaurin. So Maclaurin is about knowing the Maclaurin formula, but we're also going to be looking at the Taylor formula. Okay, to practice more on Maclaurin, let us look at 10b. 10b, we must get the answer that has been obtained there. But first, if they say you need to obtain the Maclaurin polynomial, we need to write the Maclaurin formula. From the Maclaurin formula, we get all the derivatives, we substitute the 0, and then we substitute into the Maclaurin formula, and we're able to get the answer. Please think of that and make sure you understand this very, very well. Make sure that you understand this very, very well. The aim is to understand Maclaurin in this lesson. So we're going to focus on the problems that pertain Maclaurin, but also we shall move to the third 7 problems that focus on Taylor. So now we're going to proceed to problem 10b, and 10b seeks to highlight the kinds of things that you need. So we continue to 10b. Let's look at f of x. So now we have f primed. The derivative of the ln is 1 over 1 plus x. But you can also write it as 1 plus x to the minus 1. One plus x to the minus 2. Two, 1 plus x to the minus 3. Fourth order, which is minus 6, 1 plus x to the minus 4. Let us find this at 0, 0, 0. But because we're dealing with Maclaurin, we need to use the formula. Pn of x is f0, f prime of 0. Of 0. The third derivative which is f4 or factorial x to the power n and factorial. F of 0 is 0. F prime of 0 is 1. Just put the zeros everywhere. F of 0 is minus 1. F, the third derivative, f triple primed, it's a 2. F quadruple primed of 0 is a minus 6. Okay, so let's continue. Okay, now let's look at the fourth order. So we're going to look at P4. You make N4 in this formula. What is f of 0? It's 0. The second derivative is 1. The second one is minus 1. The third one is 2. The fourth one is minus 6. Which means P4 of x. X minus, so this one is going to be x squared over 2 factorial, which is just 2. 3 factorial is 6. If you divide 6 by 2, you get a 3. That's x cubed out of 3. 4 factorial is is 4 times 3 times 2 times 1, which is 24. Which is 24. Because 4 times 3 is 12. 12 times 2 is 24. 6 goes up in times of 24. It goes 4 times, which is actually fourth power out of 4. And this is the Maclaurin series. So what you need to do to learn the Maclaurin series, you need to learn this formula. Always Pn of x is f of 0 plus f prime of 0 x over 1 factorial, f double prime of 0, x squared out of 2 factorial, f triple prime of 0, x cubed over 3 factorial, plus f4 of 0, x to the power 4 factorial, plus dot dot dot, plus f(n) of 0, x to the n factorial. And therefore, we substitute the function values at 0, and then we get the answer, and that is the answer. We move on to the next thing. We move on to the next thing. So the next question. Right, so the next question therefore becomes as follows. So this P4 is exactly the same as what they got here. Okay, let's look at the next thing. Let's look at the next thing. Okay, let's look at the next thing. Right, so look at the next thing, then we continue to look at the next problems. The next problems must be mastering Taylor, because that is the objective of this lesson. So we're going to move to the Taylor, because we saw the Taylor problems. Right, we're moving to the Taylor problems in tab 7. Okay, here is the Taylor. Okay, but this is not exactly the nth remainder yet. It's the fourth order Taylor polynomial of ln x about x equal to 1. So now, when they say you need to find the fourth order Taylor polynomial, so now this Taylor polynomial, so there's something we call the nth order. Nth order Taylor polynomial. So what is the nth order Taylor polynomial? This is the formula. So the formula is going to be the following. So this one is going to be Pn. Normally it's Pn comma A, like this, of x, which is f of A. F primed of A f primed of f double primed of a over 2 factorial f triple primed of a. Okay, this one is squared minus a, you cube this one. Fn a over n factorial x minus a, the nth power. So now you need to, this is the formula for Taylor, this one. But it is a formula for Taylor about a nth order polynomial polynomial for f at a. So now what do they have here becomes the following. Right, so let us deal with this. So we do the same things like we've been doing. We find the derivatives. Okay, but now it is find the fourth order polynomial of ln x about x equal to 1. So f of x is ln x. Choose some different color, perhaps red. Let's find the derivative. What is the derivative of the ln? It's 1 over x. The second derivative is minus x to the minus 2. The third derivative is 2x minus 3. The fourth derivative, you can just put 4, the fourth derivative, which is minus 6x to minus 4. F of 1, 0. F primed of 1, 1. F double primed of 1, minus 1. F triple primed of 1, 2. The fourth derivative at 1, minus 6. Okay, so we found the derivatives, and then now we are going on to do the Taylor. So this Taylor is going to be done in a couple of stages. So we're going to look at the fact that we're interested in the fourth order. So it's going to be P4, but it's evaluated at 1 of x, which means it's evaluated about 1, so it's going to be f at 1, f primed at 1, x minus that, f double primed at 1, over 2 factorial, f triple primed at 1, 3 factorial, the fourth one, And then you have over 4 factorial. Okay, let us put the division carefully. Well, you can put it like that, but from the formula just below the F. So you can just put it below the F, below the F, below the F. So that we have P4, 1 of X. What is F of 1? Right, so it means therefore now we've already got F of 1, which is 0. F prime is a 1. F double prime is a negative 1. You have X minus 1 squared. Triple prime is a 2. Quadruple prime is a minus 6. So that with the following. So this is X minus 1 minus 1 half X minus 1 squared. 3 factorial becomes what? Becomes a 6. 2 goes how many times into 6? It goes 3 times. You can write it like they wrote here. So this 2 you can write as 1/2 like this, but you can put it at the bottom like this. This 3 factorial, it's 6. 2 goes how many times into 6? 3 times. So we're practicing Taylor. X minus 1 cubed, 3. And then minus X minus 1 to the 4th power. 4 factorial is 24. 4 goes means something 24. It goes 4 times. This is the answer. This is the answer. This P of X 4, 1 is this. This is the 4th order polynomial about 1. And this is the answer. Any question about the Taylor? Because it's everything you need to know about the Taylor. Every problem is going to be done like this. Every problem will require the formula, and then you perform the substitution. But I want us to do more of these. For example, you can be able to find an estimate of that and show that the error, right, show that the error of the approximation is less than 10 to the minus 5. So you can show that. Right, so, but now first things first, this is about the Taylor polynomial. This is about the Taylor polynomial. This is about the Taylor polynomial. So that is something that you need to take note of. Let us see if I can find other problems on the Taylor, and then we shall go back to 6b. Check 7. Write down the first 4 terms of the Taylor polynomial for this. And use your result to find an approximation for this. Okay, you can find the approximation, but we're practicing Taylor. Let's do Taylor for number 7. The answer is already there, which is this. Right. So now Taylor, like we said before, it becomes P N A of X, which is F of A. F primed of A, X minus A. X minus A squared. Okay, I'll put a 2 at the bottom of the F. So you have this one. And then you're going to have F to the 4th derivative. And then you raise it to the 4 factorial, and then you go on and on and on. 1, 2, 3. N of A to the N over N factorial. So this becomes the Taylor. Now, we need to deal with the function F. So it is the 4th root of X. Let's just find the derivative. So now you have this. You have 3 out of 16. The minus 7 out of 4. The 3rd derivative is going to become exactly 21 out of, what is 4 by 16? 64. X to the power minus 11 out of 4. This is minus 11 by 21. Okay. So you can use a calculator. Just check these answers. So you have, for example, 21 out of 64 by minus 11 out of 4. (21 out of 64 times minus 11 out of 4. Okay, and this is minus 231 over 256. Minus 231 over 256. Minus 231 over 256 x minus 15 out of 4. So now you have 16. And then here you put 16. What is the 4th root of 16? You put 16 raised to this. 16 is 2 to the power 4, so that this is only 2. So the 4th root of 16 is 2. F primed of 16. You take the 4th root of that, it becomes 1/4, and then you have 16 minus 3 out of 4. 2 out of 4. 4 cancels, which is 1/4. 2 to the minus 3. 2 to the minus 3 is what? Is 1 out of 8. And 4 by 8 is what? 32. $16. Which is, yeah. Yes, you must just memorize the Taylor formula, this one. Right, and then we're just doing the 7 Taylor, but the answer is already there. Is this one here, but we'll just check that we're getting this answer. Okay. And then you can see they're writing it like that, so it's okay. Now we're dealing with the second derivative here. I'm just doing the rough work of the numbers here because this one is involving some fractions. Like there's minus 3 out of 16, but here you put the x is 16 to the power minus 7 out of 4. It's only this Taylor formula, this one. And then we did the Maclaurin. But the Maclaurin, the difference between the Maclaurin and the Taylor is that the Taylor has A here and the Maclaurin has 0 wherever there is A. So then you have this one, the 16 is 2 to the power 4. And then this one cancels, and then you have this one. The 4 cancels, which is 2 to the minus 7. What is 2 to the minus 7? 3 over 16 is 2 to the 4. 2 to the 7. And then it is minus 3 over 2 to the 11. All right, so that's what we're having. 2 to the 4. And then 2 to the 7. And then it becomes 2 to the 11. Now that's very interesting, but yeah, that's what we're getting. And then minus 4, which is minus 7 out of 4. 1 out of 32. Okay, need to check this because they're getting a 12 here. Okay, so let's see, this is 4 squared. 16. Which is 2 to the 4. Okay, it appears that we're getting minus 3 over 2 to the 11. 1 over 2 to the 5th power. $16. So you'd have the following. So you have the following. So now you have 16, which is minus 11 out of 4. 2 to the 4. If this, so this one is 2 to the 5 is 32, then 2 to the 6 is 64. 2 to the 6 and then 2 to the 11. And then there is 2 to the 17. And then this is 7 by 3. 21, 2 to the 17. But there might be an extra thing that's going to come out of it. Yeah, from the denominator. So this one is 21 out of 2 to the 17. Okay, so we're going to stop there. But and there's an extra one you can get. Because they said, so this 1, 2, 3, 4. So you need the first 4 terms. So let us remove this. Let us remove this. Let us remove this. Now, then it's P. The first 4 terms would be, okay. 1, 2, 3, 4. So you need 1, 2, 3, 4. So 1, 2, because you need the first 4 terms. 1, 2, 3, 4. Then you're going to stop at the 3. So which means that n is going to be 3. P3, comma 16 of x, because it is about x equal to 16. What is f at 16? In other words, you're going to have f at 16. F primed at 16. 16? Right. F double primed at 16. And then you put 2. F triple primed at 16. And then you have 3. Then you're going to stop there because these are 1, 2, 3, 4 terms. And you need first 4 terms. So P3, 16, x. F at 16 is a 2. F primed of 16 is 1 over 2 to the power 5. So it is 1 over 2 to the power 5. And then x minus 16. Double primed is minus 3 over 2 to the power 11, but there is also this 2 factorial. X minus 16 squared. The triple derivative is 21 out of that. 21 out of 2 to the 17. 3 factorial. Which is 316. Which is 2. 2 to the power 5. X minus 16. 2 to the power, so the 2 factorial is like 2, and then this is 2 to the 12. This one, x minus 16, and then you square it. This 21 is 3 times 7, giving us 7 at the top. Now the 3 is going to cancel 3 in the 6, giving us 2, and then it's going to give us 2 to the 18. X minus 16 cubed, which is exactly this. So now, this is the second problem we've done on Taylor. And then obviously we're yet to do the remainder. Right. To say, use your result to find an approximation of this, estimate the error of your approximation. Right, we are yet to look at the nth remainder, but you said it's not in the test. So we're just making sure that you understand the Taylor at the moment. And then we're going to look at the remainder. But you can see that this is the Taylor, which is the P316, which is exactly that. But they don't even put the P3, 16. Okay, but some books do that. Some books do that. But they don't appear to include that. Let's look at one more problem on the Taylor. I want to check maybe number 8. Also, question 8 might have the Taylor also. We shall move on to number 8 and check if the Taylor problem is there. Okay, good. Now, yeah, you have the Taylor. So let us do Taylor also in number 8. So now, the Taylor, we've already seen that it is Pn at A of x, which is f of A, f prime of A, x minus A, over 2 factorial x minus A, over 3 factorial x minus, okay, this is squared, cubed. And then this is Fn of A, x minus A, n over n factorial. So this one is the Taylor formula. But you can see, I think that in your book, in your class, they might just be saying Pn. They don't put the comma A here to indicate the center. So which is the same thing. But then we just need to confirm this answer, then we're going to do the remainder formula as well. But obviously, said the nth remainder is not quite part of what is emphasized in the test. So we could do that in a way. So, but now let us look at the Taylor polynomial to approximate sine 44. To approximate sine 44, first, it means that you're dealing with sine x. So it means that f of x is sine x. Therefore, its derivative of the sine becomes cosine x. The second derivative is minus the sine. But you need to look for the first 3 terms. So you're going to look at the third one. The third derivative is minus cosine x. I said that the aim of this lesson is to master Taylor and also to master Maclaurin. So we have done the formula for Taylor and then we're doing the formula for Maclaurin. But now you need to be able to evaluate these at the 44. Right. So you need to be able to find the sine of 44. The question is what exactly therefore becomes the sine of 44? Right, so to find the sine of 44, okay, 44 degrees. 44 degrees is 44 degrees. You need to multiply it by what? By pi over 180 degrees. Okay. Now this is what we have, which is 44 pi over 180. You can write it like that. Over 180 is the same thing, but you can simplify this further. So this is exactly what we have because you multiply pi over 180 degrees is what we use to convert from degrees to radians. Radians. So now you need to find f of a. So you need to find f of a, and the a is what? Is 44 pi over 180, which is the sine of 44 pi over 180. Okay? And therefore, you shall actually be in a position to obtain the answer. And then now, you actually continue to do the rest of this until you have the things that come out of that precisely. And then you would have that one as well. So in principle, if you have here, this one is going to be 44 pi over 180. Over 180. Which is minus the side of 44 pi. And then you have this one, 44 pi out of 180. Okay. This is what we have. And then now, so you can evaluate these at those points. Can evaluate these at those points. But you can see that now these are not very nice numbers. If these are not very nice numbers, you can do these. You can see that this was done about pi over 4. So let us do this about pi over 4, because these are not very nice numbers. You can do this about pi over 4, because this one is just an estimation. Let's do it about pi over 4. 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 So let us simplify this. One over the square root of 2. 1 over the square root of 2. 1 over the square root of 2. 1 over the square root of 2. Okay, if we expand about this, about pi over 4. Let's do that, and then we shall get the try to do that. So you have f of now first 3 terms. So first 3 terms 1, 2, 3. We're gonna cut here. That's squared. That's squared. It means that we're gonna do 2. And then now I'm suggesting we do it about 45 degrees pi over 4 radians. Let's see what we get. It's gonna be f of, I'm suggesting pi over 4 radians. F primed of pi over 4 x minus pi over 4. F double primed of pi over 4 out of 2 factorial, and then x minus pi over 4. And then we have pi over 4. F of pi over 4 is 1 over the square root of 2, which is this. And then f primed is again 1 over the square root of 2. F double primed minus 1 over the square root of 2. F double prime minus 1 over the square root of 2, which is this one. Okay. Which is this one. X minus pi over 4. And then P, we have the following. You have the following. So now, P2 of pi over 4. Okay, which is just P2. And then it's called F, and then you're going to replace every X by that. The pi. 44. If then you replace 2 pi over 4, you replace by 44 pi over 180. Let's see, you have 1 over the square root of 2. 1 over the square root of 2. In the place of the x, you put 44 pi over 180. Pi over 4. 44 pi over 180. You square it. So you have 2 pi and 4, 44 pi over 180. Which is 1 over the square root of 2. Now here, I need to write clearly, so this is 44 pi over 180. Okay. So this is 44 pi over 180 minus pi over 4. So what is this? What is this? Okay, let us check this out. Think of this and find the estimation of this one. Check the taskbar and launch the calculator and just do some algebra. So you're going to have, for instance, 44. You have 44 out of 180 pi minus pi and 4 and then you divide by 4. So what you're getting is, you see, from the 44 pi that you get minus pi over 180. Minus pi over 180 radians. So note that one. So that is going to become, this one is going to be minus pi over 180. So it's going to be minus 1 over the square root of 2 pi over 180, which is exactly this one. So even this one, the 44 pi over 180 minus pi over 4 is minus pi over 180, but you square it, so it becomes plus. It becomes exactly plus. But again, because this one the second derivative is the 2 factorial, so it's going to be an extra 2. This extra 2. So which is pi out of 180. Like that. Okay? Which is this? Which is exactly that one. Any question about the Taylor? Here we use the Taylor just to estimate. But this was a very interesting one, but very tricky because you see that we found this about an angle. And we chose because it was 44, and then we chose 45 degrees. Pi over 4, which is exactly 45 degrees. This is what we found this about. Any question on this, Taylor? Let's check number 9 and see what it has. All right. Okay. Okay. I was looking. So yeah, by and large, it's what we need. It is what we need. What we need. Any question about this, Taylor? The Taylor formula, it's there that you did the Maclaurin formula. Also, now with this, then you can do any problem, like literally any problem. You know, can do literally any problem. All right, you can do literally any problem. All right, literally you can do any problem. So you can think of a question you have. But what does Taylor need? The Taylor method requires you to just know the formula, the PNA formula, which is f of a plus f prime, the blue formula. X minus a plus f double primed of a over 2 factorial x minus a squared, f double primed of a 3 factorial x minus a. That is the formula you need. That is the formula you need. That is the formula you need. That is exactly the formula you need. That is exactly the formula I need. Any question? Yeah, just pausing. We're not rushing. Okay, see, can we please touch the chap on power series? Okay. And then I get that we can use 1 over 1 minus x and Do you use it everywhere? Yeah, everywhere. Struggle with finding the sigma notation or whatsoever that sigma formula is. Okay, let's check the sigma formula. Let us check the sigma formula. So, okay, yeah, this sigma formula in the 1 over x, 1 over 1 minus x, okay? Let's see. We're going to the sigma formula in the 1 minus x. Okay. We use it everywhere whenever we see 1 over 1 minus x. Okay. Um, like, so now, so, okay, we continue. We continue. Now, okay, we have this. Checking, let me see. Let's see. Okay, just going through the tasks to see the kinds of problems. See this one taught. So, for example, if you have this 7, okay, let's see. Just looking for the problems that you can do on the kinds of stuff. I think those problems feature, yeah, here, Part 7. So let's recap on these Part 7 problems that you have the sigma notation, the sigma formula. So these problems here, they need us to actually focus on, for example, the one over 1 minus x. Okay, so x squared, x to the 4th power. So now you have this, which is 3 plus plus 2x. Okay, so we're just recapping on this one because this is the formula. 1 over 1 minus x is this. But the sigma, this one is written in sigma, k equals 0 to infinity, and then x to the power k is written like that. So that at this point, you're going to have the following. At this point, you're going to have the following. You want to express this exactly in this form. This 3 must become 1. So that you have 1, 1 minus x. So this 3 must become 1, this 3. How does it become 1? You factor out 1 over 3. And this becomes 1 plus 2x over 3. Minus 2x over 3. 1 out of 3. Then you have minus minus. Minus minus, therefore, is going to become the sigma, like this. But, I mean, you can write out the terms, you can write it in two ways. But the best becomes, the easiest becomes, you can write the sigma, because it's already 1 over 1 minus x. 1 over 1 minus, this is our x thing. K equals 0 to infinity. This thing is our x, and our x becomes, therefore, the negative 2x out of 3. And then you raise it to the power k, which is 1 out of 3, k0. 2x to the power k, 3 to the power k. You multiply by the 3, 2x to the power k, and you have that. Which means you have minus 2x out of 3. For convergence, this one must be less than 1. This thing here, the absolute value of minus 2x out of 3. And then the absolute value would make the 2 out of 3 positive if the modulus is less than 1. This would mean that the modulus of x is less than 3 out of 2, which is this 3 out of 2. So the modulus of x is less than 3 out of 2, but also this summation is this. This summation is that. So that's what we have, yeah. So we have shown how to use the 1 over 1 minus x, because the formula you need to know. 1 over 1 minus x is 1 plus x squared plus x cubed plus x to the fourth, and so on. And then it is a summation from k equals 0 to infinity of x to the power k. You can write it in sigma notation. Now the question is, how do you know that this is this? It is this summation formula, because it is 1, 1 minus x, then it becomes a sigma x to the power k. So this thing is our x here. Just put it in the place of the x, which is minus 2x over 3 to the power k. Then we write this. But this is true for modulus of x less than 3 over 2. Modulus of x less than 3 over 2. So that's the answer. Yeah? Okay, why add 1? Okay, good. Why add 1? We're adding 1 because there are two 3's. There's this 3 here, and there's also 3 to the power k here. So if you have 1 over 3, if you have 1 over 3 outside, this one. And then there's also 3 to the power k, this one. So if you multiply them, what you get? This is 3 to the power 1. 1 times 1 is 1. 3 to the power. And then here, you add the powers. K plus 1. That is why it's k plus 1. All right? But again, this 1 over 1 minus x is this, and then it can be written in sigma notation like that. But this 3, 1 over 3, and then 3 to the power k appears. And then when you multiply, you get that. Okay, please let me know when you understand that. We're going to take a break and be back at 4. We'll have to try and be back at 4 if you are free at 4 in the morning. And then we can see, we can do more. But also you think about what you need to do. You think about what you need to do. It's just after, it's 1 now. It's exactly 1 right now. It's exactly 1. So it's 1. Okay. Right. Think about it. Any question on this one? Then we're going to take a break. Be back at 4. Going to take a break and be back at 4. And then we'll tackle some problems at 4 in the morning and see what next we need to do. But I'm going to make this recording available now in the next couple of minutes immediately when we're done. I'm going to send this recording to you so that you can watch this recording and make sense of the things. Okay. That is what you're going to do. Right. Any question? Think about it and make sure you understand this. And then we're going to send you the recording, and then you're going to watch the recording. Going to watch the recording. And then we're going to practice more. Maybe we're going to engage more in the morning. And maybe I can add more problems on the chart. I can go to the textbook before we meet and get some problems started before we can do more problems. It's not only about the chart questions, but it's about understanding the topic in general. So doing the textbook problems can also be very, very useful. Right. I must thank you for joining us. It was awesome having this discussion until 4 a.m. I think it's good to say take care and chill, relax a little bit. And then by 4, we need to start, even if it can be a bit late, by 4:30. Maybe if it's difficult to wake up, but we still can catch up and do something at least in the morning hours. And engage more. Maybe I can give you some quiz questions. You can try some and we can mark, something like that. That you can just see the mistakes you could make, even like new questions. Beyond that, like the tart questions, but new questions. Okay. I must thank you for joining us. It was awesome having this discussion. This recording is coming in the next couple of minutes. This recording we did now is coming in the next couple of minutes. Right. Thank you so much for joining us. It was awesome. Until 4 a.m. or even if we're a bit late after 4, it's okay. But I think we need to say goodbye for now. Take care and relax a little bit. Thank you. Goodbye. Goodbye. Right.